All right, so sine inverse of x has the graph that looks like this, right? And that's really taking the sine graph that you know, and at 0, y equals to x, and x is a tangent line, and if you have x and y on y equals to sine of x, and you switch x and y, and then what happens is that this goes over there and that goes over here. So what was bent this way now gets bent this way. What was bent that way now gets bent that way. So that's why you have this graph there. And the reason I say this is what's happening is because if you switch x and y, you have x equals to sine of y. And if you solve this for y by taking sine inverse both sides, then these cancel and you get y equals to sine inverse of x. So this is really the graph of y equals to sine inverse of x. Yes?
So does that mean that 3 doesn't matter? Besides, like a graph.
Oh, no. I did. Okay, so the question was, does that mean this 3 doesn't matter? It does matter. Now, what does this 3 do?
Like raise it up.
No, it stretches. It stretches 3 times in the y direction. Okay. So, good question. So we have 3 here. So what it does is, if the original graph was something like this, like that, then it stretches so that now it reaches like that. Okay? Yes?
So if it was like, so if it was like y equals sine of x, that would be not the magnitude, but
amplitude. So
right?
you learned that if you had the graph of y equals to 3 sine of x, 3 is the amplitude because it stretches in the y direction.
Oh.
Yeah.
Oh, okay, never mind.
Yeah.
Okay. Thank you.
Okay, so that's the picture, and because we are only on quadrant 1, remember it's 1, 2, 3, 4, right? So in quadrant 1, you have here, and then you have, here's pi, and in quadrant 1, this is the area that we want to find. Okay. Now let's try to find out where they meet by plugging in, or setting them equal to each other. So you have sine inverse of x times 3 equals to pi. So that sine inverse of x is pi over 3. So that x is equal to sine of pi over 3. If you move the sine inverse to the other side, right? What is x then? Anyone? Sine pi over 3 is?
60 degrees.
Pi over 3 is 60 degrees. Sine 60 degrees is? Radical 3 over 2, right? Pi is 180 degrees. 180 divided by 3 is 60 degrees. And sine of 60 degrees is radical 3 over 2. Okay, so we actually know the coordinate of this, which is radical 3 over 2, comma pi. That's this point. And we're looking for that area. Now, here we are faced with 2 possible choices. Remember, the way we are finding area is sum of its parts. And dA is our choice, right? Usually you choose either this horizontally or vertically. Actually, there are infinitely many possible ways to chop this into small dA, which we don't discuss here, but in Calc 2, you can do polar coordinates, and you may be able to cut it in a radial way, like that, or maybe radial way, or circular way. And there are infinitely many choices to cut this into small parts. Okay. Here we only do 2 things: either horizontally chop or vertically chop. That's the only thing that we do. Okay. All right. So here. The picture seems to be fine either way, don't you think? Right? If you cut it this way, it's top minus bottom, right? Or if you cut it that way, it's right minus left. Okay? And we can actually try to do both and pick which one we like the better. Right? So let's try it that way. Okay? First, if I do top minus bottom, the top graph is y equals to pi. And the bottom graph is y equals to 3 sine inverse of x. So we're doing top minus bottom, which means I'm calculating these vertical lines. Now those vertical lines must be thickened in which direction?
Why?
No, look, you have a vertical line. We have to thicken it. We have to thicken it like this. What is this length?
The x
That's dx, right?
Sorry.
So that must be multiplied by dx. And it's perfect because this is already a function of x, right? So having dx is fine. Okay. And then you have to integrate, x goes from where to where? X goes from 0. That's where here, right? That's the x value.
The radical 3 over 2.
And radical 3 over 2 is the maximal value of x. So that's one way to do it.
How do we treat pi?
Pi is a constant, so if you integrate pi, you get pi x.
Oh,
The more challenging one is integrating sine inverse of x. Do you remember how to integrate sine inverse of x? It's
isn't that the rule?
what rule?
The rule that you give us in the test. It's
No.
like
That's how you
log A.
integrate the result or something. Not result.
So it's integrating one trick. Yes?
Is it a sine negative 1x plus cosine negative 1x?
No, that's not how I do it.
One?
You think of sine inverse of x as 1 times sine inverse of x, and you do integration by parts, where you integrate one and differentiate sine inverse. It's very involved. You don't want to do it that way. Okay, so although this is a doable calculation, if you actually do it this way, it's going to be several pages. Oh, not too many. Probably 2 pages. Okay. All right. So let's do the other method, which is to take this region, but do it horizontally. Okay. Now, if you do that way, which way do we have to thicken?
The one.
dy. This one we need dy. Right? But then you have to do right minus left, right? So we have to figure out the equation for this one and also this one.
C2 minus C1.
Okay, so it's like C2 minus C1. Let's think about what C2 is. How is C2 described? Y equals to 3 sine inverse of x, right? But we don't like this because if we do C2 minus C1 to put in here,
We have two separate
you have to
variables.
write in terms of y, right? So we have to solve this for y. How do we do this? No, solve this for x so that x becomes a function of y,
You
right?
divide by 3 first.
So you divide by 3,
And then do sine to get rid of that.
sine inverse of x, and then you apply sine both sides. So what do you get? Sine of y over 3 equals to x, right?
And then
Right?
I have a question.
Yes.
So if you took the integral of just that, would that pop out as just 3?
Yeah, that's a lot easier to integrate. We know how to integrate this. This doesn't require integration by parts. It's a simple shortcut method, right? It's 3 times negative 3 cosine y over 3. Yeah, that's easy to integrate. Okay. So this will be actually sine y over 3. How about C1? What is this one? What's the equation for this? It's right on the y-axis. What's the equation for this C1 curve? Yes?
Wait, so,
Y equals 0.
I have a question.
Yes.
Okay. So you do, like, you know, the last one we have to do it, like, in terms of y.
Right.
Why did we do it? Why, isn't it already in terms of?
This, no. X is a function of y. Okay, so let me think of it like this. Why do we want to write in this form? One way to say it is like, oh, it's dy, so we better have these as functions of y. Another way to think of it is, when you calculate this length, you're taking the difference between the x coordinates, right, for a given y. So what this does is that if you specify a value of y, see, y goes through, let's see, dy. Y goes from where to where? Where's the
Goes from 0 to
0
pi.
pi.
0 pi, right? It goes from 0 here and then goes all the way to pi. So every time y moves from 0 to pi, your value of y is being given. But then for each value of y, what's calculated is the x-coordinate of this right-hand point. And you're really taking the difference between the x-coordinates. That's how you're calculating this area. That's why it must be solved as x equals the function of y. That's what we actually did in the previous example when we had horizontal cuts. Okay? So that's that. Okay, what about this one? Huh? No, y equals to pi is this one, not this one. What is this equation?
0.
X equals to 0. This is x equals to 0. Right? So because we're taking the difference between two x values, x equals to this and x equals to 0 should be subtracted. So that's why we have to calculate. Now this is 10 times easier than calculating this. This is really a lot easier than doing the other way. Okay? So if we actually do this, integral of this is -3 cosine y over 3. Using the shortcut, right? The reciprocal of 1/3 is in front, right? And sine integrates to negative cosine. And then you plug in pi and 0. If you plug in 0, you get -3 cosine pi over 3. And then minus of -3 cosine, and you plug in 0 into y, you get cosine 0. Okay, tell me what cosine pi over 3 is.
1/2.
Good. So it's -3 times 1/2. What's cosine of 0?
1.
1. So it's negative of -3 times 1, so it's plus 3. So the final answer is 3 over 2. Okay. Now to get the same answer this way would be really hard. That's why you need to know how to cut it in both ways. Sometimes the picture just says, oh, cutting it horizontally is much better than vertically. But sometimes the equation that you get might say, oh, you probably want to do it the other way.